So what topic we are discussing? Okay. So this part is we did it for RL network. Okay, transient. So same thing is applicable for RC network. So guys, how you will solve the RC network? Okay. So suppose you have okay, let me show you. This was your RL network. Now we'll do for RC network. So this is your R and this particular parameter it's C, and it's having a voltage across this parameter is, we can take the voltage as how much, positive negative, that is V naught I am taking. Okay, and this is at t is equals to 0 the switch is getting closed. This is my R, this is my C. So earlier what was happened earlier? Okay, what was happened earlier? When this switch was not closed, when this particular switch was not closed, so when this particular switch was not closed, see, this is your RC network, and in the RC network what I am telling, we will get the final equation Vc of t is equals to Vc infinite minus Vc infinite minus Vc of 0 plus into e power minus t by tau. So this is my equation. When my t is equals to 0, so what the v naught value you are getting means your v, assume this particular is your IC current and this is your plus minus Vc. Okay, so plus minus Vc we are getting. So just wait. So plus minus Vc will get. So guys, what I want to say you, we got the equations yesterday. We got the equations of IL of t, that is IL of infinity plus IL of 0 plus minus I of infinity e power minus t by tau. So we derived like this. Okay, we derive like this. We have chosen that I of 0 plus is equals to I of 0 minus is equals to I of 0. Okay, here also what will happen, your Vc 0 plus, this Vc 0 plus, this switch was open, so this circuit is disconnected. You having a circuit like this only, nothing is connected, no current is coming, so plus minus Vc value will be what? Vc value will be what? 0. Vc 0 minus is equals to Vc 0 plus is equals to 0. So this value we are getting, Vc 0 minus is equals to Vc 0 plus is equals to 0. Okay, now when we will connect this switch from position 1 to position 2, so how the circuit will look like? The circuit will look like this. Circuit will look like this. It's connected. Okay, this is C, this is plus minus V0, and this is my R. So if I'll write the current equations or voltage equations, what I will get? Minus V0 plus I am assuming this is my IC current, because IC into R, and I am assuming this as plus minus VC is equals to 0. Okay guys, okay. So if you'll solve this current, what is the, we know that V is equals to L di by dt. Current is equals to I is equals to C dV by dt. Well, got this equation. So you have to substitute this. This is your IC value. For capacitor, this was for inductor, and this is valid for capacitor. So substitute this value, minus V0 plus C dV by dt plus Vc is equals to 0. So what value you will get? You will get one equation. Okay, so what equations you are getting? Dv by dt, C dV by dt, you are getting V0 minus Vc, and dV by dt value is, and this is your Vc only, so it's a Vc only, so this particular is your Vc only. So V0 upon C minus 1 by C into Vc. Okay, so we are getting the equation like this: dou Vc by dou t is equals to V0 by C minus 1 by C into Vc. So see guys, what we did for this, we got the equation like this: Vs by L minus IR, something like this we got. Okay, we got the equations like this. So these things we can break into two form. This particular equations we can, this particular terms we can break into two terms. Our Vc of t will be Pi plus complementary factor. So in yesterday class, what we had seen, one was forced response. Complementary factor is for natural response, and Pi is for forced response. So what the things you will make 0? What the things you will make 0 in this? For finding the forced response, what you will make 0? Guys, what you will make 0? V0. For finding the forced response, you will make V0 is equals to 0. So what you are getting? dVc by dt to minus Vc by C. Okay. Now if you will solve this particular term, if you will solve this particular equations, dVc by dt is equals to minus Vc by C. So what you will get? Oh, I miss one point here. R is there also. R point I had missed it. So RC will come. Okay, RC. So if I want to solve this particular term, so my VC will come down, dou VC by VC minus 1 by RC into T. Integrate both sides. So if you will integrate both sides, what you will get? ln VC of T is equals to minus 1 by RC into T plus some A dash value. And VC of T, what you will get? E power minus T by RC plus or just take it like this, E power A dash, if all the things will be there. So VC of T, I am writing this as a term only, A e power minus T by RC. So this is what? This is your forced response. This is your forced response. Okay, so we got our forced response like yesterday. What we did, we got our forced response. Now for finding the complementary function, what you will do? Oh, sorry, we got the value of, this is our natural response, because we make force as a 0 na. So this is our natural response. I'm really sorry, natural response, because we make the external input voltage what we were having, we make it as a 0. So we are getting that VC of T is equals to A e power minus T by RC. So natural response, this particular is your natural response. Okay, so I'm really sorry, this is your natural response. So we got the value of a natural response. What about the force response? For force response, we have to see the steady state value. Okay, so in steady state, what will happen, guys? In steady state, how the circuit will look like? Positive, negative, and the capacitor was there and your resistor was there. So this is my capacitor, this was V0 value, this is my capacitor, and the steady state value, we know that 1 by j omega c. So capacitor will become infinite, because if you put the frequency as a 0, it will become infinite. So we'll get the circuit like this, it get opened. Okay, it will get open. So if it is getting open and the I current will in a steady state will be 0, so what plus minus VC will get? VC of T, what will get? That is V0. So VC of T will be equal to V0 only. That is your VC of infinite is equals to V0. So we got the, now this is your what response? Forced response. We'll say it is our forced response. So what is the overall response you will get? VC of T is forced response plus natural response. So if you substitute this, so you are getting V0 plus A e power minus T by RC. A e power minus T by RC. This is your VC of T. Now you want to get the value of A. So put the value of a VC of 0, V0 plus A e power minus T by RC. You know the VC of 0 value was 0. Already we calculated. So 0 is equals to V0 plus A e power minus T by RC. So guys, what will the value of A? What will be the value of A? Minus V0. A is equals to minus V0 e power T by RC. Right? A will be minus V0 e power T by RC, like this what we had solved yesterday, what we are getting a plus vs by r. So what we are getting, we are getting this particular thing. Okay, so what I want to say you, here the thing is that you had substituted the value of a t is 0, so this part is 0, so this part is 0, so you are getting a value as minus v naught only, minus v naught only. So vc of t, and you can write like this also, vc of 0 minus v naught is your a value. If you will substitute this value in
So that is a equal to minus v naught divided by e power t by r.
But what I am saying, I am just substituting the vc as a 0, so e power minus t by rc will become 1 na.
Okay.
Yeah. E power minus t by rc will become 1. So what I am getting, the a value is vc of 0. That's why I have written vc of 0, write like this, 0 plus vc of 0 plus minus v naught, a value, and substitute this value in your equation. Vc of t is equals to v naught plus vc of 0 plus minus v naught into e power minus t by rc. So what you are getting, the final equation, vc of t, v naught is representing what, v of infinite, plus vc of 0 plus minus v of infinite, e power minus t by rc. So we can write this equation like this also, vc of infinite, take minus common, vc of infinite minus vc of 0 plus e power minus t by rc, and 1 by rc is your tau value. So you can write vc of t is equals to vc of infinite minus vc of infinite minus vc of 0 plus e power minus t by tau. So yesterday I told you that we'll derive this equation, and see, this is nothing, it's a very easy, very simple thing. We need to get the equation like this. Okay, we need to get the equation like this. So how we did it, we assume our circuit like this, v naught, and it was initially open. So open circuit means no current is flowing in this. You are getting a terminal like this, so there is a no current. So what will the value, this is not connected, this particular thing is not connected. So what is the value of a vc, initial value will be 0. So vc of 0 plus is equals to vc of 0 minus is equals to vc of 0. This is the property of a capacitor. Capacitor does not allow sudden change of voltage. So now when this circuit will connected, when we'll connect this switch at 0 plus, our circuit will be like this, correct? We'll get the circuit like this. Now what I did, I form a KVL. This is our KVL. So in a KVL, minus v naught plus ic into r plus vc. Okay, now we are getting this equation, and we know that ic is c dv by dt. This dv actually denote for vc, voltage across the capacitor, dvc. So dvc by dt. After solving this, I am getting rc dvc. This all are dvc. I hope you assume this dvc. So rc dvc by dt is equals to v naught minus v of c. Now I am getting the value of a dvc by dt is v naught by rc minus this is your rc, 1 by rc minus vc by rc. So if I'll solve this differential equation, so this differential equation will be break into two parts, particular integral and complementary functions. So guys, yesterday we discussed there is a two kind of a response. There is a two response, right? Just wait. So there is a two response. One is transient response, one is steady state response. So for transient response is known as a natural response, and steady state response is known as a forced response. So for force response, voltage will be there, your input parameter will be there, but for transient response, input parameter will not be there. So remember this point. For force response, steady state value we have to consider, and for natural response we have to ignore the source parameter. Okay, and which is known as a yes, see. Okay, so complementary function means if I am finding the complementary function, that means I am doing the natural response. If I am doing the particular integral, then I am doing the forced response. Okay, so same thing I had applied here. For particular integral, what I am doing? Forced or natural? Forced. And for complementary function? Natural. So in this, what will happen? Input sources will be 0. But in this, we have to consider the steady state value at infinite amount of time, what it's happening. So see, if I want to find the complementary function, that natural response, I had made my V0 value. V0 was my input parameter, so I made it as a 0. So I am getting these things, dou Vc by dou t minus Vc by Rc. Now after solving this, I am getting this equation. So I found it for the natural response. So complementary function we did it, we found it. But for forced response, we have to do steady state analysis. So at infinite amount of time, what will happen? This capacitor will store all the energy of this. So if it will store all the energy of this, so it will become V0 only, and V0 minus V0, the current will be 0 only. So that's why we are just removing this capacitor and making it as an open circuit. Okay, positive, negative, and this is your R. So if it is open circuit at infinite amount of time, what the Vc of infinite you will get? V0. If you are assuming here positive, negative, Vc infinite, you are getting V0 value. So we got our forced response. Add both this equation, forced response and your natural response. So forced response and natural response both are added, we are getting the equation like this. But you need to find the value of A. For finding the value of A, put Vc t is equals to 0. So, and you know the Vc of 0 is 0, but I am not substituting this parameter because I have to derive the formula. So Vc of 0 plus is equals to V0 plus A e power minus t by Rc. So it will become 0. So I will get the value of A is how much? Vc of 0 minus V0. Vc of 0 minus V0. Here I had assumed 0, that's why. Here I had assumed like a Vc of 0 plus minus V0. So I got the value of A. And substitute this in the formula. So you will get the formula. And your Rc is your time constant. Yesterday itself I discussed what is the time constant with respect to charging and discharging. In case of charging, what is your time constant? Time constant is that time when it reaches the 63.2. It was 63.2% of the final value.
Initial value.
Final value means at a steady state value, what the value it's getting. Okay, like it have to reach 5 na. So at this time, 5 into 63.2 percentage by 100. At what time it's getting the 63% of its final value? Okay, that is your time constant. And for discharging, so at what time it will reach its 36.8% value of the final value, of the initial value. Okay, so in discharging you have to say the initial value, and for charging you have to say the final value. Okay, is this clear?
Yeah.
So if it is clear, then we go for the numericals. Just wait, I have to connect, otherwise it will get switched off. Charge. So guys, just revise this formula, or remember this particular two formula. If you know this two formula, the thing is very clear for you. Just hold for a second. Just wait for a few seconds. I have to connect the Wi-Fi. Guys, my screen is visible.
Yeah.
Okay. So we're discussing about the transient chapter. So the transient chapter means the main components we had finished. We had almost finished about the transient part. Now, if you'll do the numerical, then you will understand the beauty of the transient. Okay. So just wait. We'll start the transient. Just wait. Okay, guys. Okay. So so natural response, forced response. I hope you guys understood. Uh, right? Till here, everything is clear. So write one question. Find. You need to find. Question is find VC, Vx, and Ix for t greater than 0 when the initial value, initial means Vc of 0 or Ic of 0, initial voltage, it's given, initial voltage of capacitor is 15 volt. So initial value means you know the value of a Vc 0 minus is equals to Vc 0 plus. They had given the value like 15 volt. initial meanings. If they are mentioning initial capacitor voltage, so it's a VC. If they are saying that initial inductor current, so it will be current. Okay, so the circuit is like this. Circuit, it's like this. This is your circuit, and this particular is your circuit. Okay, this is 8 ohm, this is plus minus V of x, and here I of x. So you need to find, and this is 12 ohm. So you need to find the V of x value, also your I of x value also. Okay guys, so what you know in this questions, given parameter is Vc 0 minus is equals to Vc 0 plus, and this particular value is 5 ohm, and the capacitor value is 0.1 farad, and that we know that Vc. So these all are the given parameter. Vc 0 minus is equal to Vc 0 plus is equals to Vc of 0 is equals to, it's given 15 volt. Okay, and what you know the capacitor formula? Vc of t is Vc infinite minus Vc infinite minus Vc of 0 plus into e power minus t by Rc. This is the formula. We write only, we derive this formula. Correct. So what the things we know here? This parameter we know, right? C we know, right? And we have to find the value of V of x at t greater than 0. Okay, so these things we know. R equivalent we don't know. We need to find the Vc of infinite value, then our things will be done. Okay, so how you will solve this particular circuit? Okay, how you will solve this particular circuit? Just wait. So for finding the R equivalent, what you will do? You have to see from this point. You have to erase your capacitor from capacitor. Okay, for finding the R equivalent, and you need to see from this point, these two terminal where is capacitor is connected. If it is in the case of capacitor, you need to see the R equivalent from your capacitor terminal. Okay, after the final positions. So we are getting the we have to see R equivalent from this point. This is my terminal A. I am assuming this is my terminal B. So these both are in series. So 8 plus 12 is 20. So I am getting this is my 20 and this is 5. So it is my 20 and it is my 5. So what you are saying, it is parallel or series? This is 5, this is 20, this is my A terminal, this is my B terminal. So both are connected to, one is connected to A to B terminal and another is also connected to A to B terminal. So both are in parallel. So what we'll get? 20 into 5 divided by 25. So 5 into 5, 4. So we know the R equivalent value is also 4. And what will be the Vc at infinite position? So we have the circuit, this circuit, see. So at infinite position what will happen, guys? At infinite position what will happen? What will be the VC infinite value? So at infinite, now this VC value, this VC value at initial condition, it's having a 15 volt voltage. Okay, so it is discharging its voltage across this resistor. At infinite it will completely discharge, and
Yeah,
the
zero.
voltage will be zero.
Zero.
Okay, because there is a no source, it is a source free network, so at infinite it will be zero. Now you know the all value, so you got the equation of VC of t. So VC infinite minus VC infinite minus VC of 0 plus into e power minus t by RC. So what is the VC of t value? 0
Zero.
minus 0 minus VC of 0 plus is 15 e power minus t by R value we got 4. I am writing RC only. So VC of t value we are getting 15 e power minus t by RC. If you will substitute your value, what you will get? 15 e power minus t, R value is 4, R equivalent value across capacitor we had seen it is 4, and C value is 0.1. So it will go upside, it will become 10. So what value we are getting? 15 e power minus 2.5 t voltage. So this is my VC of t value. Okay, VC of t value. Now if you will put the VC t as a 0, you are getting 15. If you will put infinite, you will get 0. So my equation is correct only. So guys, we know the VC of t value with respect to time. We got the value of VC of t. Now what you have to do, you need to find the Ix value and Vx value. So apply the nodal analysis, take the reference point. Okay, and this is your VC of t value. So this both are in series connection. So if you want to find the Vx of t value, what will happen? VC of t into 12 divided by 20, voltage divisor rule. This will multiplied with this and divided by this plus this. So we are getting Vx of t value is how much? 15 into 12 divided by 20 e power minus 2.5 t volt. So you will get, I think, Vx of t is 9 e power minus 2.5 t volt. And if you want to find the Ix of t current, so VC of t divided by 20. So what value you will get? 15 e power minus 2.5 t divided by 20. Right? So this is the correct answer. Means if you solve this, what you will get? 0.75 e power minus t divided by 0.4. Just wait, guys. Just wait. Light has been cut down. So just wait for a few seconds. Today there is a network problem issue. Let me connect. Screen is visible, right?
Yeah, it's visible.
So we are getting 0.75. Okay, so 0.75 minus t divided by 0.4. So is this clear? This question is clear for you? You understood this question? See, what was the question?
So can you show me the starting of the problem?
Yeah, this is the starting of the problem. So what they had asked, you have to find VC value, that voltage value, Vx value and Ix value for t greater than 0. Okay, for t greater than 0. And your initial value of the capacitor is given. Okay, initial value of the capacitor is given 15 volt. Okay, now Vc0 minus is equals to Vc0 plus is equals to 15. Okay, so you need to find the V of X value, voltage across resistor, and Ix value. So for that we know one equation, we know the voltage across the capacitor formula is Vc infinite minus Vc0 plus e power minus t by Rc. So what I did, we know the value of a Vc0 plus, that is 15. We have to find the value of a Vc infinite, and we know that there is a no source. So at infinite amount of time, this capacitor will discharge. It's discharge the current from here. The voltage will be completely vanish, and you will get the voltage 0 at infinite position. So we know the value of a Vc infinite is also 0. But you don't know the R equivalent value. For finding the R equivalent value, you have to see from capacitor side. You are opening your capacitor. Okay, you are opening your capacitor and you are seeing the value of R equivalent. So these two are in, this particular two are in series, and this particular two branch are in parallel. So we got the R equivalent value as also 4. So from this we know the value of a Vc of t. After substituting the all value, we got the value of a Vc of t, that is 15 e power minus t by Rc. Now I know the value of a Vc of t. That means this voltage parameter, this Vc of t, we got the value of a Vc of t. Now I know the value of a Vc of t. If I'll use the nodal analysis, if I'll make it as a ground, and if I want to find the value of a current from this branch also, we can find it, Vc minus 0 divided by 5. If I want to find the current from this branch also, we can find it, Vc minus 0 divided by 20. And if you know the current, if you will multiply it with this 12 ohm, you will get it. Otherwise you can do the voltage divider rule. The same, it is connected to the parallel branch, so that means the whole voltage is distributed between this resistor and this resistor. So by doing the voltage divider rule, you have to multiply it, Vc of t into 12 divided by 12 plus 8, 20. You will get your V of X value and I of X value. Prasanna, is this clear for you?
Yeah.
Priyanka, you are getting?
Yes, sir.
Prashanti, you are getting? Okay. So see, uh, so this is the things what we have to discuss, and I just want to tell you one thing. Uh, we can, how can we draw this particular circuit? Like, this is my circuit like this. We can also, in a exam they can also give the question like this. This was how much? 5. So this is, suppose this is 5 ohm. Okay, this is 8 ohm. Instead of Vc0, they can give you like this. They can give you like this, positive negative 15 volt, capacitor was, it is the capacitor. Okay, so at t is equals to 0, the switch was connected to this before 0, less than 0 I am writing, less than 0, and at t greater than 0, the switch is moved from this position to this position. Okay, so that is representing what? Positive negative Vc value. So Vc value, Vc0 minus is your 15. The same circuit they can give you like this. It is the same representation, right? It is the same representation. So this is how you have to decode, and you will understand how this kind of a question how to solve by practicing. The more you practice, the more you learn. So suppose now I am giving you one question. Try to do by yourself and take 5 minutes time. I am giving you 5 minutes time for this particular question. Just try. The question is, you need to find VC value, IC value and Vx value for time greater than 0 when initial voltage of capacitor is 3 volt. Okay, initial voltage of the capacitor is 3 volt. Circuit is this particular is your circuit. This particular is your circuit, and its given value is 6 ohm. This is your 2 ohm. This is your positive negative V of X value, and this is your 8 ohm value, and here it's given a capacitor. This is positive, this is negative, and this C is equals to 2 farad, and this is your IC. Okay, yeah. So guys, let me tell you, assume the IC value is in this direction only. IC value, and this is your positive negative VC value. Okay, so this is your question, and you need to find the V of X value, IC value, okay, Vx value, Vc value and IC value. You have to find this Vc value, IC value, Vx value. So time means it's 9:57. I am giving you 5 minutes time to solve this. So at 10:05 I will ask you guys. At 10:05, up to 10:05 you have a time. Okay, so try this question. Have you noted, everyone? Prasanna noted? Priyanka noted this question?
Yes, sir.
Prashanti, you noted? Okay. So okay guys, solve it. You have a 5 minutes time. Guys, anyone solved?
Yes, sir. Solved.
How much you got the answer?
VC of t is 3 e power minus t by 8.
Wait. VC of t you are getting
3 e power minus t by 8.
3 e power minus t by 8.
And IC of t is
IC of t is
minus 3 by 4
minus 3 by 4.
e power t minus t by 8.
Okay. So minus 3 by 4 you are getting.
Yeah.
Okay. For you, Priyanka, same or different?
Ix is different, sir.
3 by 4 e power minus t. How much you are getting, Priyanka?
3 by 8.
3 by 8 you are getting. IC or IX? IC value, na? Yeah. 3 by 8. Okay. So guys, let's solve this question and let's see what you have done. So guys, just tell me, what is the initial value VC of 0? VC of 0 minus is equals to VC of 0 plus. What it's 3, right?
3.
So this value is 3. Done. What will be the R equivalent? We will see from here. R equivalent
4.
8 into 8 divided by 16. This is one branch and this 6 plus 2 will make you one branch. So these both are coming as parallel. So you will get 4.
4.
R equivalent is 4. So what is the equation of VC of t you will get? VC of t is equal to VC infinite. Infinite will be how much? Because there is a no source, it will be 0. So VC infinite, VC of infinite minus VC of infinite minus VC of 0 e power minus t by RC. So this value is 0, this particular is 0. So we are getting VC 0 e power minus t by RC. So how much you will get? VC of 0 value, VC of 0 value is 3. E power minus t, what is R value? 4. And C value is?
4.
C value is 2.
2.
So you are getting VC of t is 3 e power minus
e power minus t by 8.
t by 8. That is correct. Okay, you got the value of a VC of t. What will the value of a V of x? V of x will be VC of t.
VC of t into 2 by 8.
So you will get V of x is equals to 3 e power minus t by 8 into 2 by 8. So 3 by 4 you will get.
4.
So V of x value you are getting 3 by 4 e power minus t by 8.
T by 8.
So guys, what I told you, you need to find the value of IC. Okay. So what is the equation for IC? I is equals
C
to
into dv by dt.
dv by dt. So I is equals to C into d by dt. And what is the VC equation you got? 3 e power minus t by 8. So I value is 2 into 3
So we can take the
e power minus t by 8 divided by
1 by 8.
minus 1 by 8.
Minus 1.
So you will get IC value is minus 3 by 4 e power minus t by 8 ampere. So this value you will get. Priyanka, you understood what
Yes, sir.
where you had committed the mistake? Okay.
That's C value, sir.
C value. So that is the things only. So it's not a very difficult question. It's a very easy question, and they are asking these questions for a 2 marks. Okay. So you understood this concept, guys?
Yes, sir.
Okay. It's a very good job you did. Now we'll move to the next question. This was the story of a capacitor. Now they can develop a very difficult questions from this concept. Okay, so if you'll practice the easiest questions more, the difficult will always be easy for you then. Okay, just try this question, guys. Now let's try this question. You have 10 ampere. This is at t is equals to 0, the switch will get closed. And here you have 1 ohm. Okay, this is 1 by 2 Henry. This is I value. Okay, and this particular is your you need to find the value of I of t for t greater than 0. Okay, you need to find the value of I of t for t greater than 0. Find I of t for t greater than 0. So guys, this is not a very difficult question. So how was the circuit? Means before closing, at t is equals to 0 it is closing. Okay, but when the circuit was not closed, then how was your circuit? At before t is less than 0, 10 ampere, 1 ohm, it was open like this. So there is a no, so this will become your irrelevant part if it was open. So no current will go, so it will become my irrelevant part. So I am getting I of, this is my inductor current, so I of 0 minus or I of 0 plus is equals to how much? 0 ampere, right? When the switch is getting closed, now the circuit will be okay. When I am getting the switch as this as a closed, so yeah, so this part is closed, so my circuit is becoming like this, right? At infinite amount of time, if the circuit will be at after t greater than 0, when switch is closed, so at infinite amount of time, what will happen? This will become short circuited, right? My inductor will be short circuited na. J omega L, frequency is 0, so it will be short circuited. So if this is short circuited, this is my I current. So what will be the value of this? This will become irrelevant, because current will always wants to flow from the shortest path. So current will go like this. So this path also become irrelevant, and this path also become irrelevant. So whole circuit will be simply replaced by this. Okay, means you have the value of I infinite is how much? 10 ampere. Because this part will get short circuited. If this will be short circuited, current will directly flow from this. It won't go in this. It will not distribute it. And here also, it will not distribute between this and this. Okay guys. So you got the value of a I infinite. I infinite is equals to 10 ampere. What about R equivalent? For finding the value of a R equivalent, you need to, this was 10 ampere, this particular is 1 ampere. You need to open your inductor like this, and you have to see from anywhere. This is your A, this is your B, and this is your 2 ohm. So this is independent source. This is independent source, independent current source. So for finding the R equivalent, what we do? Open circuit current source. Now if you see your RAB, so RAB is what? RAB is 2 into 1 divided by 3, 2 by 3. Now substitute the value, every value in these equations. I of t is equals to I of infinite minus I of infinite minus I of 0 e power minus RT by L, because we are doing for a current source. Okay, so I of infinite we got 10 ampere, I of infinite we got 10 ampere, I of 0 we got 0, e power minus t into R value we got 2 by 3, and L value is 1 by 2. So and 1 by 2 it will be 2 only if it will go upside. So what the equation you will get? 10 into 1 minus e power minus 4t by 3, 4t by 3. Let me check one thing. This is 2, this is 1. Okay, okay. Yeah. Understood, guys, these things? Guys, is this clear? Guys, is this clear? Or you want one more explanation? Prasanna?
Yes.
Okay. So this way we can solve our inductor and capacitor part. So it's not a very difficult things. It's a very easiest part of the chapter. So it's and if I'm giving you one question, suppose we have one question. It's suppose this is your 3 ohm, this particular is your positive negative 20 volt, and so this is 9 ohm, this particular is your 1 ohm, and this is 20 microfarad. This is positive negative VC. Okay, and at t is equals to 0, switch is getting at t is equals to 0, your switch is getting, earlier the switch was connected to this phase, and at t is equals to, this position is at t is equals to 0, the supply is getting on, supply is getting off. So in this question you need to find the value of a VC of t for t greater than 0. So before t less than 0, how was my connection? My connection was like this: 3, 9, 1, and this is my capacitor. This is 20. So guys, at infinite amount of time, what will happen with the capacitor? 1 by j omega c. It will get infinite, so it will be open circuited. So if it will be open circuited, there will be a no current. So how much voltage we are getting across 9 volt? 20 into 9
20 into 9
divided by 12. 3, 4, 5. 15 volt. 15 volt. And the current here is 0. So what is the VC value? It will come 15 only. Minus 15 plus 0 into 1 plus VC is equals to 0. So VC 0 minus you are getting as a 15 volt. So VC 0 plus will also be a 15 volt, and VC 0 also be a 15 volt. Now you got the initial value, and what they are saying now your supply after t greater than 0, your supply is becoming like this. Only you will get this particular circuit. This 1 ohm, this 9 ohm, it will cut off, and this particular positive negative VC, that is 20 microfarad. Okay, 20 microfarad. So guys, okay, even if my supply is low, what will happen with the capacitor voltage at infinite amount of time? Now it will get completely vanish if it will be look like this. After infinite amount of time, the VC of whatever the VC initial value of a VC was 15, so it will get vanish. Okay, so VC of infinite, how much you will get? 0. It will discharge across this resistor, and it at a time, and one time will come, then this VC of infinite will become 0. So VC of t will be how much? VC infinite minus VC infinite minus VC of 0 e power minus t by RC. So we know the value of a VC of infinite, that is 0. It is 0. This particular is 0. This particular voltage is 0. So you are getting VC of 0 e power minus t by RC. So VC of 0 value, how much we got? 15 e power minus t by RC. But you don't know the value of a R and C. C value you know, but you don't know the value of a R value. R value, we have to always see the value of a R after t greater than 0. So after t greater than 0, the circuit is looking like this. Okay, this is my capacitor, so we need to open it, and we have to see from this point. This is 1 ohm, this is 9 ohm. So what value of R will come? 1 plus 9, 10. So we got the value of R as a 10, and C value is given how much? C value is given how much value? The C value is given 20 microfarad. So put the value, get the result. VC of t is 15 e power minus t divided by 20 into 10 microfarad. That way we will get 1000 upside. So this cancel out, and this it will 5. So VC of t you are getting 15 e power minus 5 t volt. Is this clear, guys? Understood?
So can you explain me once again VC of 0?
What problem you are getting?
VC of 0 value.
See, this is my circuit. Okay, so initially the supply was connected like this. So my initial supply I got, this particular. Now if it was if it was connected from the minus infinite amount of time to some particular zero amount of time, so that means it is in the saturated position. All the voltage, whatever the capacity of the voltage of this capacitor, it get stored. Okay, and even will do 1 by j omega c, so it will also become open circuit. So if it is becoming an open circuit, so that means its a current is 0. So from here what I did the voltage divider rule, because it's getting open. So 20 into 9 divided by 12, I am getting 15 volt. If I got the voltage as a 15 volt, so what was the amount of a capacitor voltage stored? This is a 0 ampere current, so minus 15 plus 0 into 1 plus Vc. We are finding for Vc of 0, so that's why. So Vc of 0 we are getting 15 volt. So this is my initial capacitor voltage storage. Okay, now at t greater than 0, my circuit is getting like this. So this is my circuit at t is greater than 0. So this initial voltage, initial capacitor voltage, what it store 15 volt, it's charged. So all the voltage what it's charged, it will get dissipated. The energy will get dissipated across 1 ohm resistor and 9 ohm resistor, and Vc of infinite will become 0. Vc of infinite will become 0. So now you have to substitute the value 0 minus 0, and you have to see the value of a c value. We always see after t greater than 0. So open it and get the value of a c. What we are getting, 9 plus 1 10. Put the value, get the result. Is this part is clear?
Yeah.
Priyanka, you understood? Priyanka, you understood?
Yes sir. Yes sir.
Okay, if you understood, then it's very good. Now you have some circuit like this. Now it is a very interesting question. This question is very interesting. Find the current I of t for t greater than 0 when the initial current of inductor is given as 10 ampere. So this is your inductor part, and this particular is your 2 ohm, this is your 4 ohm, this particular, it's a dependent source, 3i, and the value of here inductor flowing is I value. The value is 1 by 2 Henry. This is 2, this is 4, this is 3i. So solution will be, go for a solution. I of 0 minus is equals to I of 0 plus is equals to I of 0. It's given as a 10 ampere. Okay. What will happen at infinite position means this inductor will completely discharge its value, right?
0.
Yeah. So I of infinite will be 0. directly, we can say. It will completely dissipate its current across these things.
Resist.
Yeah, this register. But you need to find the value of R equivalent. But here it is given source dependent. Okay, and it's depending upon this particular source. So what we'll do? We'll assume one test source, or you can take it like this. This is my V. I am assuming as a 1 volt source, and I am assuming this is my I current, and this I is equals to minus I by this circuit. So we need to, for finding the value of resistor, we need to find the value of V is equals to I into R. So R is equals to V by I. So we assume the V voltage as a 1 volt. We need to find the value of I. This is my 2 ohm. This will be 4 ohm, and this particular will be positive, negative, minus 3I. Okay, so solve this and get the value. Assume here as a this is a 1 ohm, 1 volt only, because this particular parallel. So I will be equal to 1 by 2 minus 1 by 2. I will be equal to this current plus this current. So plus 1 plus 3I by 4, 2 by 4. So 4I is equals to 3 plus 3I. So how much I current you are getting? You are getting 3 ampere current. So what is the value of resistor? V is equals to I into R, and V is 1 volt and I is 3 into R. So R value is 1 by 3. Now put all the value. I of t is equals to I of infinite minus I of infinite minus I of 0 e power minus RT by L. So I of infinite 0, 0, 0. So I of 0 we are getting, and I of 0 is given as a 10 e power minus RT by L. So 10, R value how much we got? 1 by 3 into T, and L value is 1 by 2. So 1 by 2, so it will go upside. So 10 e power minus 2t by 3. This I of t value. Understood, Prasanna? Is this clear, or you want?
Yeah, how you have taken that 1 plus 3I by 4?
1 plus?
That is current source, right? I mean, we are doing V by R.
What you are saying? So this particular things you are not understanding.
No, so that 1 plus 3I by 4.
See, actually, this is your current source. This is your voltage source. Actually,
Okay.
it is dependent
That's
on
why
current, but it's your voltage source. Plus minus. See, it's given like plus minus. If it was the current source, na, so the denotations will be like this.
Okay, sir.
Okay, so that's fine. So we are getting, we have to, I already taught you in the dependent source concept in that class. We have to assume as a test source, and then we have to take okay. So that's why because we are having here a dependent source, so we cannot calculate the register. We need to perform this test source. Okay, while performing this test source, we'll get the value of our register, and we got the value of register. Priyanka, you understood?
Yes, sir.
Okay, so if you are means if you guys will be very sincere about this class from the beginning, now you will not face any problem. And if you'll miss the classes, then definitely, because all are linked, all the concepts are linked. So you have to be very sincere, and you have to revise all the topics. So write down, note. When we see the dependent source in circuit, that time we connect simple 1 voltage source, or you can current source also. It's up to you. If you are connecting the current source, then you need to find the voltage across the current source according to the simplicity, according to the simplicity to finding the equivalent resistance, to finding the equivalent resistance. Okay, now I am giving you one question, or I will try to solve for you guys. Just see, you have a
So can you please show me the previous slide once?
diagram you need.
No, last one.
Okay.
So okay, you can continue.
See, you have a figure. This is 2 ohm. This particular is a positive negative 20 volt, and this is okay 1/16 farad, and it's given a current source I/2, and this is your 1 ohm. This particular, it's 3 ohm, and here it is I current. Okay, you need to find I of t. So I of t means this particular, for t greater than 0. Now you have to assume that things. Okay, so how you will solve this question, guys? So how you will solve this question? At t is equals to 0, the switch is getting open. At t is equals to 0, the switch is getting open like this. That's given. So initially the switch was closed. So at t is less than 0.
T less than 0.
At t is less than 0, how was my circuit? 2 ohm, positive negative 20 volt. This is my capacitor. This was my I/2. This particular is my 1 ohm, and this particular is my 3 ohm, and this is my I value. Okay, my circuit was like this, and you need to find the value of a VC 0 plus. So means at t is less than 0, the circuit was at infinite position. Means it was going like this, going like this at an infinite position. So that means my capacitor was open circuit. So if my capacitor was open circuit, so I have something like this, positive negative 20 to
Sir, what if we consider t is greater than 0, then also the capacitor will be...
Yeah, means see what I am telling now. See, you have a your circuit is operating from minus infinite to infinite time. Okay, so minus infinite to infinite time now. At position 0, what I did, I moved the capacitor switch to some other position. Okay, so from this position to this position, it's having an infinite amount of time. So in that infinite amount of time, what it's happening, if I'll put the, if in that infinite amount of time, my transient is not taking place, but transient is taking place at what point? When we are the switching the capacitor positions. It's this minute point from 0 minus to 0 plus. Okay, at this point only the transient is taking place. Okay, 0 minus 2 means suppose some particular some you assume some microsecond. Okay, so it was already, this circuit was already in a infinite, ideally saturated, all the capacitors it's already, the capacitor is charged. So that's why the capacitor is already charged. That means what, you are putting the capacitor value as 1 by j omega c, that is infinite. So that's why it's becoming 1 by 0, you are putting it's infinite. Man means what, because it's covered the infinite distance, minus infinite distance. So although it's a infinite distance only, so it's covered the infinite distance. So that's why I'm making it as a open circuit. Okay, and we need to find the value of voltage at the infinite position, and my infinite position is what, it's coming like this, and at 0 positions it's covering the infinite. And here I am checking the what is the value of that voltage, right? So this is I by 2, and this is 1 ohm, and this is 3 ohm, and that is I. So how you will do this calculation? It's very easy. Assume v minus 20 divided by 2 plus v by 4 is equals to I by 2. And what is the relation between v and I? v divided by 4 is equals to I. So I is equals to how much? V by 4. So if you will solve this, 2v minus 40 plus v divided by 4 is equals to v by 8. You will put the value, so you will get 2. So how much value you are getting? 3v minus 40 into 2 is equals to v. So 6v minus v is equals to 80. So v value is coming how much? 80 by 5. 80 by 5 will be 16, I think. 16 volt. So this is your 16 volt. This particular is your 16 volt. Means this capacitor, this is a capacitor which is open. So VC is also 16 volt. Right. So VC from minus infinite to 0, that means VC of 0 minus you got as how much? 16 volt. And VC of 0 minus is equals to VC of 0 plus is equals to VC of 0. Now you got the VC value. Now the circuit will become at after t greater than 0. After t greater than 0, your circuit will be like this. This is 1, this is 3 ohm. So what will happen? This capacitor voltage VC of 0 minus we got as a 16 volt, means charged value. final charge value of the capacitor is 16 volts. So now we got something, some charged value of voltage we got. So it will discharge, the capacitor voltage will discharge at infinite amount of time. If will go from 0 to infinite, and the VC of infinite will become 0. So VC of infinite will become 0. Now you need to find the value of R. What you will do? Assume 1 volt here. Assume I current here, capital I. Okay, because small I is given. This is your, it's I by 2. This is your I by 2. And this particular is your 4. And this is your I. Okay guys, and this is 1 volt. 1 volt. So what is the value of I? I is getting 1 by 4. So what you are getting, one current as a 1 by 4 here, and this is I by 2, so 1 by 8 current will. So what will the value of I? 1 by 8 plus 1 by 4. So I value you will get 3 by 8. So what will the capacitor value? V is equals to IR. V you had assumed 1 volt, and I you got 3 by 8. So R value you will get 8 by 3 ohm. So what value of a VC of t you will get? VC of t you will get VC of infinite, that is 0, minus VC of infinite, that is 0, minus VC of 0 that we got as a 16 e power minus t by RC. So 8 by 3 into C value is 16, 1 by 16. So 1 by 16 means it will go upside. So this will get cancelled out. So VC of t value you are getting 16 e power minus 60. This 3 will go upside. So 60 you will get.
So okay. How we got that 1 by 8 over?
1 by
8.
Where? I value is 1 by 8. See. This particular value is I by 8. I by 2. And what is the value of I we got? Oh, I did mistake here. So this is 16. So 16 by 4, 16 by 4. No, it's correct only. We assume the test charge voltage is how much? 1. So 1 divided by 4, 1 by 4 we will got 1 current. And 1 current, oh, it's coming in this direction. Na? It's coming in this direction. So it will be 1 by 8. So what will be the I equation? I equation will be, apply the KCL. So incoming current is I plus I by 2 is equals to I. So I will be I minus I by 2. So I current we got 1 divided by 4. 1 by 4 minus this will be 1 by 4 into 2. So 1 by 4 minus 1 by 8. So I current will come how much? 2 by 8. So it will come 1 by 8. So guys, it will be 1 by 8. 1 by 8. So R will be 8 ohm resistor. Prasanna, understood?
Yes.
So R will be 8 ohm resistor. So it will be 8 ohm resistor. So it will come 2. So e power minus 2t. 16 e power minus VC of t we got 16 e power minus 2t. So now we know the circuit. Circuit is like this. Okay. So we know this particular circuit. Okay. So it's getting open at t is equals to, after t is greater than 0. I am drawing, and this particular value 1 by 16, and this particular value I am getting I by 2, and this particular is 1 ohm, and this particular so 3 ohm. But you need to find the value of I. We got the value of a VC of. So how you will do it? What is the current? Means this particular, this you had assumed positive negative. So this means your IC of T current is in this direction. So apply the KCL and tell me the relation between this IC of T and I. So IC of T is how much? IC of T, incoming current. Incoming current is I by 2. And outgoing current IC of T plus I is equals to I by 2. So IC of T is how much? Minus I by 2. So I is how much? I is minus 2 into IC of T. So what will the value of IC of T? C dV by dt. So C value is 1 by 16 and d by dt, and VC value we got 16 e power minus 2t. So what we'll get? Minus 2 into 16 divided by 16 e power minus 2t. So we'll get IC of T value is minus 2 e power minus 2t. And what is the I value? I value is minus 2 into IC of T. So minus 2 into IC of T. So substitute the value of IC of T. So you will get 4 e power minus 2t ampere. Is this clear, or you want one more explanation?
Once
more you want. See, listen very carefully. See, this is your circuit. This particular is the switch, and they are saying that this particular point is T is equals to 0. T is equals to 0 means earlier the switch was closed earlier, because we are opening this switch at T is equals to 0.
Yeah, T less than 0 it was closed.
So if it was closed, so we are assuming the circuit like this. We have the circuit this. Okay, so this circuit was operating from 0 to some I'm assuming minus in terms of a minus. Okay, from minus infinite to some 0 point it was operating. Okay, so what will be the steady state value of this? Means it is getting charging. Okay, see, if you have one 5 volt battery, and if you have one capacitor, so at one time will come na, this capacitor will get fully charged, right? All the 5 volt battery, all the electrons will get accumulated, means this will become positive, and this will become negative. This will become a 5 volt source. When this is, and assume here some resistance is also there, R is also there. So one time will come, then when it will become this 5 volt, all the battery potential will come across the capacitor. So if this is 5 volt and if this is 5 volt, that means what? The current is 0. 5 minus 5 divided by R. 5 minus 5 divided by R. Current we are getting 0. So that's why at final positions, when the capacitor is getting fully charged, that's why I am representing this like this as an open circuit. Okay, means my capacitor, I am assuming it's fully charged. Okay, so this capacitor, I am assuming it's fully charged. Fully charged means the current across the capacitor will come 0. Okay, now you have this particular, or assume, or you can take a frequencies f as a 0, you will get xc value is infinite, so you can directly open it. So my capacitor is get opened. Okay, so this, here we have a capacitor but it's open, and this capacitor is connected parallel to this. So if I'll find the value of this voltage, so this voltage will be equal to this capacitor voltage. Correct? Right?
Yes.
So now, and I know the value of this current will be 0. So I need to solve the circuit. Very easily I can solve it. V minus 20 divided by 2. V by 4 is equals to I by 2 current. And what is the relation between I? So V by 4 is equals to I, because I is here also. And it's a dependent source. So I got the value of I. While substituting the value of I am getting the V value as a 16 volt. That means at final position means my capacitor is getting charged up to 16 volt.
16.
So this was my minus infinite time, and it's coming up to 0 time. Okay, at 0 time. At 0 time, what I am doing? At 0 time, I am changing the supply. I am changing the switch. So this capacitor switch get changed. Now the capacitor, whatever the voltage across the capacitor, what it's charged, it will get
Dissipated in the resistance.
it will get discharge. From this point to at final one time will come when all the voltage will be come 0. So this is your infinite time. It's becoming 0. Right? So that's why I am taking Vc infinite as a 0 value, because there is no external source which will charge the capacitor. And I have this circuit at infinite amount of time. I got the value of a Vc infinite is 0. Now this thing's over. Now you need to find the value of a resistor, and here it is dependent source. So what you will do? You will connect one test source of 1 volt, because your resistor will be seen by this. Okay? Right? So here it is 1 ohm, here it is 3 ohm, here the current it's itself given is I. So this current is depending upon this. So I need to find the value of I, because resistor is equals to V by I, and V value I know 1 volt. I only assume. You can assume 100 volt, 200 volt. It's up to you. You will get the same answer. It's a test source only. Okay. So, and the relations, this is connected to parallelly, means from here to here it's also 1 volt. And if it is a 1 volt, I will get the value of I. 1 minus 0 divided by 4, I am getting 1 by 4. And if it is 1 by 4, then it's I by 2. And I by 2 is flowing in this direction. So 1 by 8. Use the KCL and you will get the answer. 1 by 8 is coming this side and 1 by 4 outgoing. So incoming minus outgoing do, and you will get 1 by 4 minus 1 by 8. And I value you are getting 1 by 8. And for resistor you need to do V by I. And you will get 8 ohm. Correct? Okay. If you are doing these things and you are getting the value of R is equals to 8 ohm. So substitute the value and get the VC of t. So VC of t, all the value substitute, and you are getting the VC of t value this. Okay. Always remember these things. This is a very important thing. If you are assuming positive negative VC of t in this direction, your capacitor current will, you always have to assume your capacitor current in this direction only, because this is positive, this is negative. So capacitor current will always be in this direction. If someone is written like this is my negative, this is my positive, then you have to assume the capacitor current in this direction, IC of t. Okay, wherever the positive, you need to, because there is a direct relation, IC of t is equals to C dVc by dt. So always follow this rule. Okay, so, and in this question what they had asked not the capacitor current, they had asked the current across the resistor. So I need to find the relations between this current and capacitor after t greater than 0. So after t greater than 0, what circuit I am getting? This particular circuit I am getting. Okay, this is my positive, this is my negative, this is my IC of t. IC of t 1 by 16. Now see the relation itself. This is my IC of t, this is my I, and this is my I by 2. So you will get IC of t is how much? IC of t is how much you will get? I by 2 minus I, that is minus I by 2. And I value you will get how much? I value is minus 2 IC of t. And you know the VC of t value. If you know the VC of t value, you cannot find IC of t. There is a direct relation. IC of t is equals to C dVc by dt. And while doing this, I use this relation, and C value is 1 by 16, and VC value I get as a 16 e power minus 2t. While solving, I am getting IC of t value is minus 2 e power minus 2t. Substitute this equation in this and get the value of I. And I got the value of I of t is 4 e power minus 2t ampere. Everyone, it's clear?
Yes, sir.
It's clear? So this was the today's story. Means you guys are facing any doubt? Prasanna, any doubt up to here?
Nothing, so once we get practice it, then we'll get clear.
Yeah, so you need to practice. That's what you had said correct only. So you need to practice these questions by yourself. Okay, and you can take my reference, that recorded videos is always I am uploading for you guys only. So you
Yes.
just watch it. Means if any concept is lagging, you can watch that concept again and again, right? So we'll discuss tomorrow. And practice this, at least this question 3-4 times you need to practice. Okay, although I had solved this
Yes.
question, but you have to try by yourself also. Okay, just wait for a minute. Okay, we did this question. Yeah, 4 e power minus 2t. Okay, just write one question and try by yourself. Okay. Suppose I'm giving you one question. It's your homework problem. It's positive, negative, 60 volt, and this is 30 ohm, this is 30 ohm. That's a switch. Okay, the switch was t is equals to 0. It's getting closed at t is equals to 0. At t is equals to 0, it is getting closed. Earlier it was open. This is 10 ohm. This particular, it is your inductor. Its value is 1 by 2 Henry. And this is I. So you need to find the value of I of t for t greater than 0. So this is your homework problem. Just try this question, and we'll discuss it tomorrow anyway, but you need to practice this question. Okay, and after this there is 3 4 question is there, separate two cases. Okay, and we have to see model 3, that is Laplace and all, RLC network, RC network, then AC transient is there. So two more class for transient, then we'll move for resonance, 6th chapter. Okay guys, thank you very much. We'll continue it tomorrow. Okay,
Yes.
good night.